review of things we talked about yesterday. We talked about the identities. We talked about the reciprocal identities. So we know sine of theta is the same as 1 over cosecant of theta, just like cosecant of theta is the same as 1 over sine of theta, right? Because they're just reciprocal. We flip them, okay? Cosine of theta is 1 over secant of theta, just like secant of theta is the same as 1 over cosine of theta. And then our last reciprocal, tangent of theta, is 1 over cotan, just like cotan is 1 over tan. We also talked about, these are our reciprocal. We talked about our quotient, where tangent, because it is y over x, could really be written as sine of theta over cosine of theta. And cotan can be written as cosine of theta over sine of theta. So those were our quotient identities. All right, and these were all in yesterday's notes. And then we did the biggie. We developed the important one, which was our first Pythagorean. And it came from, yes, it came from a squared plus b squared equals c squared, our Pythagorean identity. And that first Pythagorean identity was that cosine squared theta plus sine squared theta equals what? 1.
Will we put this in the calculator? Do you use the sine theta squared?
We're not putting anything into the calculator yet, but yes, we will do some solving soon. All right, now, from this Pythagorean identity, we said if we divided everything by cosine squared, we would get 1 plus tangent squared theta equals 1 over cosine squared theta, and 1 over cosine squared is the same as secant squared. And then we said if we went back and divided by sine squared theta, we'd get cotangent squared theta plus 1 equals 1 over sine squared, which is cosecant.
Don't you still have an x? Like when you divide tan by sine, that's y over x divided by y, so you multiply the y. And then you cancel.
I'm not sure what you're saying. If you will write that down,
Okay.
This is where I took this first one and divided by cosine squared theta. And then this is where I took the first one and divided by sine squared theta.
I thought you were dividing the second line by the, okay.
No, I went back to the first one.
Okay.
So these two come from this one.
Got it.
And honestly, I still don't have those memorized. I mean, I see them.
I was supposed to.
You must know this one. And then you can always create the other two. Okay, so that kind of summarizes all the things we talked about yesterday. Now, the one thing I didn't mention, and there was one problem on your homework, were the cofunctions. And we did cofunctions in Accelerated 1, but they looked a little different. So let's talk about cofunctions real quick, and then we'll do our review from yesterday. So cofunctions, like we know that sine of 30 is the same as cosine of 60. Do you guys remember that from? All right, and the reason we know that is if we had a nice little triangle, and this was our 60-degree angle, and this is our 30-degree angle, and this is A, and this is B, and this is C. Okay, so sine of 30 is A over C. What is cosine of 60?
A over C.
A over C. Okay, so what we knew back in the day was that sine of an angle is equal to cosine of 90 minus that angle. And that was on your milestone. So if I gave you sine of 32, you would know that is equal to cosine of 58. Or vice versa. Cosine of an angle is equal to sine of 90 minus that angle. Okay, so that's what we learned back in the day when we first started studying right triangle trig. Now, let's move that into our unit circle. So instead of 90, what are we talking in terms of? Pi over 2. Same thing. Or cosine of an angle is equal to sine of pi over 2 minus 90. They are cofunctions. Same holds true for tangent. Tangent of an angle, what do you think it relates to? Cotan. Now, we did not do this in Accelerated 1 because you didn't know the reciprocal. We didn't talk about the reciprocal trig functions until this year. So you didn't know cotangent, so that's why you didn't study it then. We only did these first two. Okay, and vice versa. And then our new reciprocal functions, secant and cosecant, have the same relationship. Okay, so these were the two we had studied before, but the same holds true for all of our functions. I don't even know that I'd write all those down. Wore out my hand. Does that make sense to everyone now? So, yesterday, we had a problem, and we talked about how to solve it the old way, because the old way was the easier way. But let's talk about how to solve something like this, using the identities. Okay? So if they tell us that tangent of theta is 3, and cosine of theta is less than 0, therefore it's negative, right? I want you to find sine of theta and cosine of theta. Okay, but this time we're going to use those identities. So take a look at what is given. Tangent of theta. Which one of those Pythagorean identities involves tangent? Because that's where we need to start. Okay, well, once again, I don't have it memorized except for this one. So I know this plus this equals this, and I need to create tangent. So what do I divide by to make tangent pop up? Cosine. So if I divide everything by cosine, this is 1 plus tangent squared theta equals 1 over cosine, which is secant. Alright, so now I'm going to plug in what they gave me for tangent, which is 3. And what do? I square it. So what is 1 plus 9? 10. Alright, I don't want secant. I'm looking for sine and cosine. So how do I solve for secant so that I can find sine and cosine? First thing I need to do is square root. Okay, when I square root, I get positive and negative when I take the square root. So you get plus or minus root 10 equals secant of theta. Okay, now secant is the reciprocal of what? Cosine. So I know that cosine of theta would be the reciprocal. 1 over. Now, it's not positive and negative. It is just negative because it was defined right here as negative. Okay? So we're just dealing with the negative. Now, when we think about tangent, if we think about that quotient identity, we know that tangent is equivalent to sine of theta over cosine of theta. Right? We just found cosine. So sine of theta over negative 1 over root 10 equals 3. So how would I solve for sine?
Divide 3 by.
Times by negative 1 over root 10. Negative 1 over root 10. So we get sine of theta equals negative 3 over the square root of 10, and leave that radical there. You can leave that there. You can leave that there. We're good. I told you back in accelerated 1 or 2 that eventually I'd let you leave the radical in the denominator. We are there. Okay, does that make sense?
More sense than yesterday.
Good, good. All right. Now, let's do another example. Example 2. So, if I had 1 minus sine squared x over cosine of x, and I ask you to simplify this. Okay. Now, let's think about that 1 cosine squared theta plus sine squared theta equals 1. What could I do? Could I move this over here? Y'all see that?
Could you also do secant?
You could do it. There are a lot of things you could do. This is the easiest. There are a lot of things you could do. So what we're dealing with is equivalencies. 1 minus sine squared x is actually equal to cosine squared x. And what is cosine squared x divided by cosine of x? Just cosine of x. Now, you might be wondering, why are we doing this?
Wait. Got it. I'm gonna start.
Okay, that's okay.
Got it.
Well, there's a little more getting it happening. I just want to make sure we get it before we move on. Okay, so this is the main guy I'm always thinking about. Is there any way I can manipulate this statement to help simplify what they gave me? Anytime I see a squared in there, that's where I'm going. Okay? And so, yeah, I can create 1 minus sine squared of x from this by subtracting the sine squared. And then, because this is equal to cosine squared, it simplifies. All right, now, the reason we like to simplify is because it helps us to later when we solve. It makes life simpler. Because if I gave you this original one and gave you a value you know, like pi over 6, and asked you to evaluate when x is pi over 6. Okay? So how would I have to think about this? All right, so let's do that. Let's bring this one down here. We're going to evaluate. So we have 1 minus, and we talked about yesterday that means the same thing as that, right? Okay? So we're going to think about it this way. And now for x, I'm going to plug in pi over 6. All right. So what is sine of pi over 6? 1/2. What is cosine of pi over 6?
Root 3 over 2.
Root 3 over 2. Alright, what is 1/2 squared?
1/4.
1/4. Alright, what is 1 minus 1/4?
3/4.
Alright, I'm dividing a fraction by a fraction, so I multiply by the
Reciprocal.
reciprocal.
It's 3 squared. 3 over 2 squared.
So I get 3 over 2 roots of 3. Now, if I were to rationalize this, I'd get 3 roots of 3 over 2 times 3. And what happens to my 3's?
Oh, 1/2.
They cancel, and I'm left with square root of 3 over 2.
That's
Crazy.
Okay? So those are the steps. That's how much work I would have to do. Alright, what did we say that's equal to?
cosine.
Cosine of x. So what is cosine of pi over 6?
Root 3 over 2.
Root 3 over 2. Which way you like better?
That's not your way.
That's why we simplified. Okay. I want to look at some new problems today, and then I want to go over some of the questions, because I bet you had some questions about the homework. All right. So these are new examples over same stuff. Just if I ask you to simplify this, what would you do?
Go to the thing.
You do the thing. You distribute.
No.
So it's sine squared x, right?
The
Yes.
Pythagoras.
Okay, so we're going to distribute, and then that's going to create something where we can think about those Pythagorean identities. Because right now I don't have anything squared. So I'm going to distribute, and I get 1 plus cosine x squared minus cosine x squared, not x squared, plus cosine x minus cosine x minus cosine squared x. Alright, so anytime I multiply conjugate, it says the outer and inners are going to cancel. So if you guys don't want to show that, please don't. Alright, and what is 1 minus cosine squared x equivalent to?
Sine squared x.
Sine squared x. Simplified.
How would you get there?
How'd I get here?
The sine.
Okay, so remember cosine squared x plus sine squared x equals 1. So if I move this over, sine squared x equals 1 minus cosine squared x.
I solved for
Oh no.
I got it.
Alright? Cosine of theta plus tangent of theta times sine of theta. These are so much fun. Alright, so we're going to simplify down to a single trig function. Alright, how can I think of tangent?
Sine over cosine.
Yes, sine over cosine. Alright, so I didn't start with any of the Pythagorean identities because I didn't have any squares, right? So I can't start there. I didn't have any squares to start with. But here they come.
Sine squared.
Yeah. Now I've got a sine squared theta. Alright. Now, if I'm trying to condense this to a single, I gotta put these together somehow. How do you do that?
Over cosine of this side. Or so you cosine.
Multiply by cosine of cosine.
Yeah.
Long.
We gotta get a common denominator. So this is gonna be by multiplying by cosine.
So it's secant.
Not at all.
Secant.
Okay, so that gives me a cosine squared theta plus sine squared theta over cosine of theta. What is cosine squared theta plus sine squared theta? 1. So we get 1 over cosine of theta, which is a reciprocal function for
Secant.
secant of theta.
I got it. Lost. You multiplied by the cosine
Yeah, me
of the
too.
green.
You got lost at the green?
Yeah.
Okay, so if I'm trying to condense it to a single, and right now I have 2 separate ones, I have to put them together. And the way I can put them together is by getting a common denominator. My only denominator is cosine of theta.
I like these.
So this one I have to create a denominator, but I can't change the value. That's why I multiplied by cosine of theta over cosine of theta. So the value is like multiplying by 1, because anything divided by itself is 1. All right? So that created a cosine squared in the numerator over cosine in the denominator so that I could combine those two. Now, is that the only way to do that problem? No. Okay? Let's envision that you got right here, saw the sine squared and went, I've got a better way, Miss Willoughby. Okay? So you may have said sine squared is the same as 1 minus cosine squared theta. And then you could have broken this up. So instead of putting it together, you could have broken it up as 1 over cosine of theta minus cosine squared theta. My brain very seldom thinks this way. And then what happens right here?
Just cosine.
Yeah, there's no squared right there. Sorry.
Cosine.
So this is secant of theta. And this is cosine of theta. So what happens to those cosines?
Cancel.
They cancel. And what do we get?
Secant theta.
Secant theta. All right. We're eventually going to get to the point, guys, where I won't do an answer key. Because there's not one way to get there. There's a lot of ways to get there.
It's gonna do me dirty.
Okay? There won't be an answer key. When we get to proofs, you know where to start and you know where to finish.
Are these?
You know the problem, you know the answer before you start. The getting there, there's lots of different ways to get there. So me posting an answer key is silly. You're not going to think the way I think. I think this way. You may think this way. Both right. Okay? All right. Let's do another. I told you were getting your money's worth today. Number 5. Okay, we're gonna get it down to a single. You know what? Let's let this be you try. This one's a you try. You try. We'll go over it in a second. I'm gonna hit pause on the video, so you can talk to me if you want to. Around. You tell me, what was your approach? What did you do?
Same thing as the other piece.
All right. So did you write everything in terms of sine and cosine?
Yeah.
Okay, that's a great place to start. So the cosecant of x would be sine of x. Cosine, and then this would be cosine over sine. Okay, so where'd you go now?
Just get an
Sine
answer.
of thingy, so you have
Call the answer.
So
Call the answer.
Cosine
You
x
get
squared.
1 minus cosine squared x over sine of x. This one was really easy, wasn't it? And what is 1 minus cosine squared x?
Sine squared.
Sine squared x.
Oh, it is.
So the answer is sine of x.
You said.
Okay. One more? Sure. One more.
Is your homework still on the same worksheet?
Yeah. I copied the same thing on the front and the back, so you could do the front or the back.
Sweet.
All right, sine of x plus sine of x times cotangent squared x. All right, when you notice something that has a common factor, you could factor it out. And if we look at this, we see that sine of x is a common factor. And if we factor it out, we're left with 1 plus cotangent squared x. All right, so in my brain, I'm going, okay, I know that comes from those Pythagorean identity, which was this. No, that's sine. It's not that. That's craziness. All right, so sine, and I want cotan. So what am I going to divide by?
Sine squared.
Sine. So if I do, I get cotan squared x plus 1 equals cosecant squared x. Oh, look right there. Those match. So what is 1 plus cotangent squared x? Cosecant squared. And cosecant is a reciprocal for
Sine.
sine. So it leaves me with 1 over sine of x, which is cosecant.
Yes, I had
Wait, how could you, yeah, how'd you factor that?
How did I, okay, so what I noticed was, at the very beginning of the problem, it had a common factor
Okay,
of sine of x. So I factored out that GCF.
but what about the
Yeah, I love
cotangent?
And
Oh,
when I
okay.
did, it left me with 1 plus cotangent squared x, which
Oh, I get it, because those are multiplied, so they're
Yes.
the same. Okay.
this Pythagorean identity tells me that 1 plus cotangent squared x is equivalent to cosecant squared x. So I subbed that in. Yes, sir.
It's like it says sine x times 1 over sine squared x.
Mhm.
How did that go to 1 over sine x?
Okay, so with multiplication, everything in the numerator is in the numerator. So what I did was I canceled one of these with one of those.
Which problems are
Okay, tonight is 20 through 38. 20 through 38. So your homework is same worksheet, 20 through 38. Okay? Now, I'm going to cut off the recording, but if anybody has questions about last night's homework, I want them now. Okay?